Hello, welcome to video 5e. This is Mr. Miller, and today we're talking about the mean value theorem. The mean value theorem is a lot like Rolle's theorem. If we have a function that's continuous on an interval and differentiable between the endpoints, then the mean value theorem says that there's a point somewhere on the function where the slope of the tangent line is equal to the slope of the segment between the endpoints. So right here in this diagram, this kind of pink dashed line is the segment that's in between the endpoints. And what the theorem is saying, there's a point somewhere where the slope equals that slope. And this function would be right there. Here, this dashed line right here, and this function represents the segment between the endpoints. And we see that there are 1, 2, 3, and 4 places where the derivative is equal to the slope of that line. Okay, that would mean that the tangent line is parallel to the slope of the segment between the endpoints. All right, that's the mean value theorem, and our job is to find the points where it's true. Okay, here's our first example. We have a quadratic function defined on the interval 1 to 4. Polynomial functions are continuous everywhere, and their derivatives exist everywhere. Okay, our job is to find the point in the interval 1 to 4 where the slope of the function equals the slope between the endpoints. So right here, this orange dashed line is the segment between the endpoints, and somewhere, looks like around here, the derivative is going to equal that slope. So we're expecting to find a point in between 2 and 3 where the derivative equals the slope of this dotted line. Okay, so the first step is to figure out the slope between the endpoints. So we have m equals f of 4, the value of the function at 4, minus the value of the function at 1 over 4 minus 1. Okay, if you substitute 4 into the equation, you get 5. So it's 5 minus the value of the function at 1. If you work that out, you get negative 1 over 4 minus 1. So that ends up being 6 over 3, which is 2. So we're going to look for a place where the derivative is equal to 2. So we got to find the derivative. It'd be 4x minus a, and we want to set it equal to 2. We want to find when the derivative is equal to the slope of the line segment. Okay, if we add 8 to both sides, we get 4x equals 10, or x equals 10 fourths, which is 2.5, which is what we thought it was. We thought it was somewhere in between 2 and 3. It's exactly in the middle. Okay, so the mean value theorem guarantees at least one point. There may be more. All right, here's our next example. So this time we have another quadratic function. It looks kind of similar here in the graph. First step, find the slope of the line segment between the endpoints. And then we got to find the point in the graph where the derivative equals that. It looks like it's down here again somewhere. Okay, somewhere around there. Okay, so first find the slope between the endpoints. So this will be f of negative 1 minus f of negative 5 all over negative 1 minus a negative 5. Okay, I did the math on this. I got 3.5 minus a negative 0.5 all over negative 1 minus a negative 5. This ends up being 4 over 4, which is positive 1. Okay, so we're going to look for at least one value in this interval where the derivative is positive 1. So we take the derivative, that would be x plus 4, and we set it equal to 1. And that's no problem to solve. We get x equals negative 3. We'll need our TI-89 later, but not quite yet. That's the point we're looking for. That's the point where the derivative is equal to the slope of this line here. The slope of the line is actually called the average rate of change for the function. It's on average how much the function changes every unit. So someplace the derivative is equal to that average rate of change. Okay. All right, we're going to move on to a little bit more complicated function. Here is the orange segment represents the, the orange segment connects the endpoints here. And it looks like we may have two places where the function has a derivative equal to the slope of the orange line. So it looks like we may have one down here somewhere. And it looks like we may have one up here somewhere. Okay, first step, find the slope between the endpoints. So this would be f of 3 minus f of negative 1 over 3 minus negative 1. Okay, in the denominator, that works out to 4. And in the numerator, we get 4 minus 0, which makes the slope is 1. Okay, so we got to look for places where the slope is 1. The derivative is negative 3x squared plus 8x. We want that to equal 1. So if I put this in standard form, we have a nice quadratic function here. And we can do the quadratic formula to solve it. So we get x equals negative 8 plus or minus the square root of 64 minus 12, all divided by 2a, which is negative 6. And if you do all of that, you get negative 8 plus or minus the square root of 52 over negative 6. And if you look at the decimals, you get x equals 0.131 and x equals 2.53. 0.131 corresponds to that point right there. And 2.53 corresponds to that point. Okay, so it was kind of where we expected. Sometimes we don't have a graph, so having the graph is kind of nice. All right, let's try this example. This example is a rational function, and I gotta admit, the 89 would be very helpful. So I pulled out the 89 to do the math for me. So it starts the same way. We find the slope between the endpoints. So we're going to find f of 7 minus f of 2 all over 7 minus 2. And if you substitute those values, you get some crazy fractions. You get 49 twelfths minus 4 halves over 5. I'm not going to lie. My TI 89 told me that that was 5 twelfths. Okay, now we have to take a derivative and find where the derivative is equal to this. Okay, now this function has an asymptote, but it's at 1. It's outside the interval. So inside this interval, it's continuous and differentiable. So our mean value theorem applies. So if we take the derivative, you're going to find y prime equals 2x squared minus 4x over 2x minus 2 squared. Okay, you can use, as I said, your TI 89 or just apply the quotient rule, and we want this to equal 5 twelfths. Now, you can do a ton of algebra. You could solve this by cross-multiplying, and eventually you should get x equals 1 plus or minus the square root of 6, which is equal to negative 1.44 or 3.45. Okay, so the graphing calculator helps a lot to take the derivative if we want and to solve this equation. Now, negative 1.44 is not in our interval, so we're not interested in it. We're only interested in points in the interval. So this one is the point in the interval. In fact, I'm going to go back and write it in its exact form. 1 plus the square root of 6. All right, time for our last one. Again, we should be able to do these by hand, but TI 89 makes this kind of easy. So this function here, we want to find the point where the derivative is equal to the slope of the orange line. Okay, so we start by finding the slope of the orange line. M equals f of 5 minus f of 0 over 5 minus 0. If you substitute 5 in this equation, you get 25 minus 5 times 5 is 0, and the square root of that is 0. And if you substitute 0, you get square root of 25, which is 5. And that's just negative 1. Okay, so we're looking for a point somewhere where the slope is negative 1. I think there's 1 over here somewhere. Okay, well, we got to take the derivative of this. I'm going to do it by hand, just to kind of review taking the derivative. Remember, when we take the derivative of a square root function, we should write it as that function to the 1/2. And we're going to use the general power rule. Y prime would be 1/2, 25 minus 5x to the minus 1/2, times the derivative of the inside function. And we get negative 5 over 2 square root of 25 minus 5x. And we want that to equal negative 1. All right, now we can cross multiply and solve this, but if you use your 89, you're going to get x equals 15/4. 15/4 is a little bit shy of 4, which is somewhere around here. Okay, so I was kind of close. Anyway, that's the point that works. Mean value theorem guarantees that if the conditions are met, there's at least one point. This brings us to the last example. You're going to like this one because the mean value theorem doesn't apply. So it turns out that this function is continuous on the interval -5 to 0. We see its graph here, but its derivative doesn't exist here at -4. So f prime of -4, which is inside the interval, does not exist. Therefore, the mean value theorem does not apply. So, there's nothing we can say. We can't do anything. How about that? We have to make sure the conditions for a theorem are met in order for the conclusion to be true. All right, time for your journal assignment. Now, in each case, you're going to find the slope between the endpoints, and then you're going to find where the derivative equals that slope. And it's okay to use your TI-89 to help you do this. All right, good luck.